Recently in one of my weekly live streams, which I do every Monday night at 5 o'clock Pacific time, I spent some time talking about implicit differentiation. More specifically, I spent a lot of time talking about the steps of an implicit differentiation problem. And I think this is a really helpful thing to talk about. Rather than just kind of going through examples of implicit differentiation problems over and over, I thought it would be helpful to kind of take a step back and really think about the steps you go through as you do an implicit differentiation problem. Because I think you're going to find this really helpful to kind of, think about the actual process you go through and write down the steps themselves. Because basically what I'm going to be giving you in this video is a blueprint that you can use to solve any implicit differentiation problem that you're going to run into. So make sure you take some notes. I'll put it down in a format that's really easy to understand and follow so that you can write it down and use it on your own. Without further ado, let's go ahead and jump into the video, and I'll show you the chunk of that live stream where I talked about the steps of implicit differentiation problems. So whenever you're doing any implicit differentiation problem, typically what the problem asks you to do is basically find dy dx is probably the most common thing that it would ask you to find. It may say something like dx dt, for example. That's another common situation that might come up. But essentially what you're trying to do is find the derivative of some function with respect to some variable. If it's dy dx, you're saying find the derivative of y with respect to x. And the type of problem that they would give you would just be some equation which relates x and y. However, it's typically not just going to be y equals some function of x. Because if you're given something like this, your y is already solved for, and you can essentially just use different derivative methods that you may know, like power rule, chain rule, product rule, quotient rule, certain derivatives that you've probably memorized. If you're given something like this, you can typically just apply those. But the type of situation where you have to apply implicit differentiation is where you have x's and y's all kind of mixed together, and you can't solve for y and get it all by itself. And that's why the differentiation is considered implicit, because we don't have an explicit formula for our function of y. So we have to use this kind of different method. So in terms of the actual steps that you want to go through, basically the first thing you want to do is look at your problem that you're given. First of all, figure out what is your function and what is your variable. So determine your variable and your function. Now, when I say that, what does that mean? Well, let's say, like I said, we are given some equation which relates x and y to each other, but all the x's and y's are all mixed together. Let's say the problem told us to find dy dx. This little thing right here in parentheses, find dy dx, this actually tells us the answer to step one. It tells us what our variable and what our function are. If you have d something over d something, whatever this letter is on the bottom right here, that's going to be your variable. And whatever this letter is on the top here, in this case it's y, is going to be your function. Okay, so dy over dx, our function is y, our variable is x. If we're told to find dx dt, that right there tells us our t is our variable and x is our function. So that answers step one right there. Sometimes they may not say find dy dx or find dx dt, and you have to use context clues. In that case, you want to figure out basically what is your independent variable, what is the variable that you would plug in, what would be your input variable, and that's going to be your variable. And then whatever is your dependent variable or your output variable, whatever the output of your function is, that is your function. So in this case, the x would be the independent input variable, and y would be the dependent output variable. In this case, dx dt, if you were in a situation where it didn't say find dx dt, but it gave you some sort of relationship between x and t, where t was an independent input variable and x was a dependent output variable, that would tell you that t is your variable, x is your function. And what you're looking for is dx dt. So that is how you want to start. Okay, so once you have figured out what your function and what your variable is, what letter represents each of those things, at that point you need to take the derivative. So essentially take the derivative of both sides of your equation with respect to whatever your variable is. So take the derivative with respect to your variable. So we're taking it with respect to whatever you determined was your variable up here in step 1. So if we're finding dy dx, we're taking the derivative with respect to x of both sides of our equation. Once you do that, you should end up with, so doing this step 2, that's basically just going to be, you may have to use different things like power rule, product rule, quotient rule. When you're doing that, what you want to be very careful of is any part of your equation that only contains x's or only contains your variable, you're just going to differentiate as normal. However, any parts of your equation that include y, or whatever your function letter is, you need to be sure to treat your function as a function of your variable. You need to treat y as a function of x. And when I say that, that's going to be a little bit easier to explain with an example, which, like I said, we'll be getting into shortly. But typically, whenever you have your y or your function letter and you're taking the derivative of that chunk, you typically are going to have to use chain rule, because you have to keep in mind that y is an unknown function of x. So that is going to end up kind of using the chain rule in most situations. And like I said, I'll get into that a little bit more when we do the examples. Okay, so then once you've taken the derivative with respect to whatever your variable is, what you want to do is you want to move all of your terms that contain dy dx over to one side of your equation, and move all of your terms that do not include dy dx over to the other side. So basically separate your dy dx terms and your non-dy dx terms. Get them each separated on each side of the equation. Typically, what that's going to look like is just adding or subtracting terms that have dy dx over to the left side of your equation, for example, and then adding or subtracting any terms that don't have dy dx over to the right side of your equation. Once you have done that, you're going to look at the side of your equation that has your dy dx terms, and you're going to factor out a dy dx, because every term on that side of the equation at that point should contain dy dx. So if you factor the dy dx out, what that basically does is it simplifies your left side of your equation, or whichever side of your equation it is. It simplifies it into a situation where you just have dy dx times a bunch of stuff in parentheses. And the reason why that's important is because what that does is it creates a situation where you only have a single dy dx term at that point. Right? So after step 3, after step 2, where we take the derivative with respect to our variable, after you do that, there's typically going to be multiple dy dx's, because there was probably multiple y's in your equation before. Once you do that, it's kind of hard to solve for dy dx until we get to this 4th step, because what that does is it simplifies multiple dy dx's, kind of condenses them down into a single dy dx. And why that's great is because once we have done that, we can pretty easily move everything that is on the same side of the equation as the dy dx over to the other side of the equation, typically by just dividing that whole side of the equation by whatever's in the parentheses. So move other terms away from dy dx side of the equation, which essentially kind of the idea there is we're just trying to isolate or solve for dy dx. So once you've done that, you should just have at that point dy dx equals a bunch of stuff with just x's and y's usually on the other side of the equation. So that's an important thing to keep in mind. Once you do this, you're probably going to have x's and y's in your answer. And that's okay. And that's why we had to do implicit differentiation, because if we were able to just get dy dx equals something with x's in it, we probably wouldn't have had to use implicit differentiation, because we could have just taken the derivative explicitly, because we would have had an explicit equation for y. So that's basically the step. Well, I hope you found that video helpful. You should have a pretty good roadmap that you can use to solve really any implicit differentiation problem at this point. And I'm guessing you probably did find that pretty helpful if you stuck around this long. So do me a favor, hit that subscribe button and that bell icon, as well as that like button down below. Both of those are a huge help to my channel, and if you do subscribe, I'll be coming out with tons more videos that you'll find helpful, and we can help, boost your grades and keep crushing it all term long in calculus. So go click that button down there. If you want to keep learning about implicit differentiation, just go click right over there, and I'll see you next time.